Alright, so this is the little tutorial for the solutions for question 6 from chapter 10. So the first thing we need to do is we need to make sure that we have filled in all of the outer values for this two-way table. We can't really do much without including some of those other values, but particularly what we need to find out is the total value over here. So not only did I add up each column and confirm each of those individual numbers, which could also help us kind of alleviate some of the work that we had to do for A, B, C, D, E, F, and G, I believe. But we could also confirm that our number 312.59 is accurate by adding up all of these values and then also adding up these two values in that column right there. We know that this is a frequency table because none of these values are percentages. They don't give us a percentage in the table. They would obviously give us that percent sign to make it a relative frequency table. And we know that this is a two-way association because there are two variables given to us. Obviously we have the age that is going to be across the x-axis, or our independent variable, and then of course we have the your living status, or your household status of living alone or living with other people on our up and down left side y-axis. So first question was, what are the two categories? And those are the two. Our age compared with if you live alone or with others. Which of these is the independent variable? It's always going to be the one that is technically our x-axis, so it would be, or across the top. The age is the independent variable because it's across the top of this two-way table, and therefore obviously the dependent variable would be the living status, with or without others, would depend on one's age in this situation because the living status is listed on the left-hand side of our table. Alright, then we have part D, which is what is the probability of living alone. We had to look up back here to find living alone, so that was our our row right here. We could have just taken that 32.73 if we had already added that up and done 32.73 divided by the total population. Or, like I did, I just showed all my work to prove all of these numbers being added up in the numerator divided by the total number in the denominator. Then we have 32.73 divided by 312.59. And therefore, we have 0.104 on our calculator, which gives us the answer of approximately 10% probability of living alone. Same thing for for being 65 or over. We would take that value, look at the column in this case. So not only would we have to look at the 65 to 74 column, also the over 75 column. What is the probability of being over 65%, being over 65, 13%. Again, we take that value, rounding, and then what is the probability of being under 65%? Oh my gosh, stop saying percent. 65. And what we do there is we could do two things. We could take our other values and divide by 312.59, or we could actually just do some simple subtraction. If you're not over 65, you are under 65, and so therefore 13% subtracted from 100% is approximately 87% of the population that was surveyed. And last but not least, what is the probability of being under 35 and living alone? We look at these two values up from our table, and therefore we would have about a 2% probability of being under 35. Remember that that does not include the 35 to 44 column, so it would only include these two and living alone. And that would be a 2% probability of that happening.